It's been a long time. So we're definitely keen to start bringing them back. They won't always be here, they'll be at different locations, but definitely at a much quicker cadence than once a year would be the ideal. So for those of you who don't know me, my name is Jason. I'm the lead engineer here at Tillo. I think I've met a lot of you while I was previously at Office Air, so you might remember me from that world. I made the jump back to Laravel, which I'm really excited about. Yeah, and a wonderful company called Tillo, which decided to sponsor all this for us, and they sponsored the venue and the food, so big props to Tillo. I actually can tell you a little bit about them just now as well, just because there's some interesting information there. But yes, just some housekeeping. So agenda as follows: we're gonna do the talk now, so we'll put a past. Afterwards, you're also welcome to hang around, have some good conversations. There'll still be pizza there, there'll still be drinks in it. If you haven't found the bathrooms yet, they're just through this door on the right. You'll see some bathrooms over there in case you haven't seen that yet. Okay, fantastic. So I'm going to do just one little bit of sharing, just to kind of honor our sponsors for today. So Tillo is a global gift card network with over 4,000 of the world's best brands. So put that on like human terms, like what's that mean? Imagine you were a neobank, imagine you were an incentive program, and you wanted to offer gift cards as a reward to your users. You could go to Amazon and like all these people individually and try and make connections with them. But what Tillo does is connect you to 4,000 of them instantaneously. So it's mostly in the US, mostly in the UK, but it is a global gift card network. Why does that matter to a room full of engineers, you might ask? Well, Tillo's recently opened a Cape Town office, which some of us in the room actually work at. So I made the jump from Office Ends to Tillo to be here in the office. And we've gone from 0 to just over 30 engineers in 8 months. And I'm sure we'll be hiring again in the future. So if you're interested in global fintech payments with local Cape Town presence, if you're involved in this type of thing, keep an eye out because we'll definitely be hiring again in the future. Great. So that's that out of the way. I'm going to introduce our speaker, Tasmyn, who's going to be speaking about an incredible topic around payments. So yeah, give it up for Tasmyn.
Okay, cool. Thank you, Jason, for the introduction. And I'm happy to be one of the speakers here this evening. It's on. Yeah, my name is Tasmyn Dube, and I'm one of the software engineers at Tillo, as Jason said. And I think before we start, I just want to get a feel of who we have in the room this evening. Do we have anyone here who's new to Laravel? A show of hands, anyone? Okay, cool. Nice. That's exciting. I think the story is then for you guys. I think when I started learning Laravel, I actually started learning Laravel instead of the language PHP. And in the beginning, I was handed a lot of the messy integration work, you know, the type of stuff that the other people don't want to do. So they're like, you go figure this out and come back and let us know what you found after that. So a lot of that was payment integrations, and many of those had the same problems. I think the same architectural problems kept on showing up, and it's the patterns that make systems difficult. And this talk is really about what I found has helped me build payment systems well in Laravel. So to start off, when you think about a payment system, I think the flow sounds pretty simple, right? A customer pays, a provider confirms it, your system updates, and everyone is happy, we all move on. But in practice, it's a lot messier than that. In the background, what you're actually dealing with is multiple systems, delayed confirmations, retries, mismatched states, inconsistent references, and sometimes there's gaps between what the provider says happened and what your system is able to prove happened. So this talk is about bridging that gap between expectations and reality. So what makes payments messy? There's a couple of patterns that repeatedly show up. I think we can start with asynchronous confirmations. Now, have you ever paid for something online and you watch that spinner going? For a few seconds, it's just going there, right? Now, during that time, what's happening? Most of the time, it's because the provider hasn't necessarily finished processing the payment yet. It may still be doing fraud checks. It may still be checking if there's checking another system altogether and doing the whole settlement process. And during that time, what do you tell the customer? So unknown states is one of the most hardest things to deal with when it comes to payment systems. And next we have retries. So imagine you receive a webhook. That webhook gets a 500 internal server error response. What does it do? It retries, right? So your code creates a payment each time. Each time it retries. And at the end of that, how many payments do you have? Exactly. Right. Next, we have reconciliation. So eventually there's going to be a payment in your DB that says one thing and the provider is going to say another thing. So who's right in that situation? It doesn't necessarily mean your system is wrong, but distributed systems don't always align. And then we've got provider quirks. So let's dive into that one. Like you'll see here on the screen, we've got 3 different providers, AWOLIC, Stripe, and HSBC. Now you see there's 3 different statuses. The one is succeeded in capital letters. The other one is succeeded in lowercase. HSBC is paid in capital. Now, technically, all of these mean the same thing. They just don't agree on the same language. Another provider quirk is references. Now, let's say you're running an e-commerce store, the customer pays, and the reference they get is ORG 12345. Your webhook comes in and you get 12345. Or you get order 12345, or you get INV 12345. Now, is that the same order? Sometimes yes, sometimes no, and sometimes maybe. Now, if your system isn't built for this, you could miss payments or end up mismatching payments. So all of these problems have a solution, and if you don't account for them early, they end up shaping your architecture for you. So I asked ChatGPT to just put a little thing together so you can see what that would look like. And you see, when you plan, you're in control. When you don't plan, the providers end up taking control of your system. Okay, so let's get into the nitty-gritty. What makes mistakes that create fragile systems? Now, these mistakes don't necessarily mean you're a bad developer. Most of them happen because your system started out small. So you started out with one provider, and then another was added, another webhook, another business rule. And code that went from 100 lines is now the hardest part of your system to change. So there are a few common mistakes that are made. There's controller bloat, payload coupling, and low visibility. So let's dive into that. When you look at this code over here, this controller, what would you say is wrong with this? I think if you ever opened a controller and started reading a method, and by the time you get to the bottom, you have no idea what it was meant to do in the first place. There's so many ifs and else's, you're completely lost in the code. So this controller, what is its responsibility? If we look at the code, it's validating the webhook, it's verifying the signature, mapping the payload, updating the payload, sending notifications, and writing logs. So the responsibility is everything. Everything is in the controller here. Now look at this. This is another method, only 4 lines. And you see, a controller shouldn't know about verifying signatures or mapping provider payloads or updating payments or sending notifications. It should just hand off the request to the parts of the system that do know how to do that. So a good controller should always be boring. Next, we have payload coupling. So let's say you start integrating with your first provider, right? Provider number 1 over there. Okay, that's the payload structure. Simple enough. You think, okay, cool, we can work with this. Then you add another one, provider number 2. The payload structure looks a bit different from number 1. Then number 3. So each of these are different. And initially, you only have to update a couple of places in your code. But then as you start adding more providers, eventually you have to update the entire thing because it needs to match the provider's JSON. So the question is, how many places in your application should know what the provider's JSON is? Ideally only one, because the moment business logic starts depending, your business logic starts depending on someone else's payload structure, you're basically handing over your architecture. Now, another one is no item potency. So let's say you're super sleepy, you need a coffee. So you go to your favorite coffee shop. Don't know about you guys, but at Tillo, we love Plato. So you get your favorite, you get a flat white, and you tap your card. And the moment you tap your card, the router glitches and the machine freezes. The cashier looks at you and says, "Oh, I didn't go through. You need to pay again." So you pay again. And this time it works. You get your coffee, you're happy, you're out of there. But now later, you go into your banking app and you realize you've paid twice for the same coffee. So the question is, why did that happen? Well, that's because the coffee shop's banking system wasn't able to see that that's the same order. So it took the money off twice. So what should have happened is the system should have said, okay, I already processed this transaction. I'm not going to deduct money. I'll just hand over your receipt. So that would be an item potent system. So what that means is no matter how many times you perform an action, the side effect remains exactly the same. So you pay for one coffee, you get one coffee. So when a provider sends a webhook to your Laravel application, it's like that barista saying you need to pay again. And if your system isn't item potent, then your customer's money gets taken more than once, or you have duplicate orders in your DB. Okay, so let's talk about weak state modeling. Imagine you placed an online order, and let's say it's for the MacBook, the M5, you're super excited, and you click order, and your bank approves your card. So it's in an authorized state. Now the payment service receives the webhook, and your application sees it as paid. So the order is confirmed, and it's shipped. But later on, the payment is actually rejected because there's some fraud check that didn't pass or something just went wrong. But now you've already shipped that package. The customer is actually busy setting up their MacBook as you speak. So what happened here now? Well, I mean, technically nothing was broken. The application just couldn't see the difference between authorized, captured, settled, and refunded. It just saw everything as one thing, as paid. And that's why it shipped off the order. So if your system doesn't move through the entire cycle of the payment, then you end up not having accurate information and you can't make accurate decisions. Okay. So another fragile marker is poor observability. I always struggle with that word. Let's say it's 4 p.m. on a Friday and you are checked out, you're ready for that cold beer waiting for you in the fridge at home. But support frantically calls you. A high value customer is very angry. The account is locked. The customer says, I paid hours ago. The gateway says it succeeded. The money is in your account, but your DB says pending. So you go to the logs, you want to now figure out what happened here, and all you see is a generic OK network log. Now, if your answer is, if they ask you what happened and your answer is, I just have to go and look through the code quickly, you have poor observability. So the core takeaway here is logging tells you what happened. Observability is being able to explain why it happened. So to recap, our fragile markers are controller bloat, payload coupling, and low visibility. Okay, so what do we do now with these problems? So we've looked at what makes your payment system fragile, but that's only half the problem. Obviously, now we need to look at what are the solutions for these things. And fortunately, Laravel has given us some really good building blocks to solve these things. And if you notice something interesting about these tools, none of them are actually payment specific. They're just really good software engineering practices. So these you can use anywhere, but we're just applying it to payments right now. So for controller bloat, we're going to use adapters and DTOs. For payload coupling, we're going to use DTOs. For weak state modeling, we're going to use enums. And for poor observability, we're going to use audit trails. Okay, so let's dive into the first one, that's DTOs. Now, let's say a webhook enters your application. At that point, who owns that data? You'd say it's still the payment provider's data, because what you're seeing is their field names, their status values, their structure, and their assumptions. So how do we fix that? How do we claim ownership back of that? Instead of letting that raw payload flow through your entire application, we map it into a DTO. We translate the provider's payload into a format our application understands. So everything before the DTO belongs to the provider, and then everything after that belongs to our application. So your DTO might look something like this here. You'll see that what's missing there is we don't have any provider-specific terminology in there. There's no HSB field names or Airwallex or Stripe. The object is speaking our application's language. So the DTO is not a translator. It's the translated document that the rest of our application is going to use. So something still has to create this DTO from the provider payload, but we'll get to that a little later. Okay, so now, if you look at this here, what happens when one provider sends confirmed and another provider sends success and another one sends settled? All of these mean success, but it would become very chaotic if our system has to understand all of those different terms, especially as you add more and more providers and each of them use different terms. So a clean way to do this is with the enum. Now, if you look at this slide, you see the first one over there. The enum defines the language of our application, and then the DTO carries that language. So the adapter will be responsible for translating provider statuses into those enum values. Okay, so now let's actually look at the adapter. So we've got our DTOs, we've got our enums, and we've standardized the language inside our application. So why do we need another abstraction? Well, because providers don't just differ in the data they send us, they also differ in how we communicate with them. So you can think of an adapter as a dedicated translator. Imagine you're having a work meeting and inviting 3 guests to your work meeting. The one speaks French, the other one speaks Japanese, and the other one speaks German. You're not going to ask your entire team to learn each of those languages, although German might be beneficial in Cape Town. Instead, what you do is you get a translator for each of them. So when they walk into the same room, everyone speaks the same language and everyone is able to then understand each other, and we can move forward with the meeting. So if you look at this example, Airwallex might have a specific endpoint to fetch an endpoint. HSBC might not even have a fetch endpoint. You might need to search by reference instead. And another provider might have something completely different. But our application shouldn't care about any of that, because all we really want to do is retrieve a payment. So this is where our adapter comes in. Each provider gets its own adapter that knows how to communicate with that provider, and the rest of your application simply asks the adapter to perform that action. So you see at the bottom, all it says is adapter fetch payment. Okay, so our final fragile marker was low visibility. So let's talk about audit trails. When something goes wrong in your system and they ask you what happened, you need to be able to answer those questions. So did we receive the webhook? Did the signature validation fail? Did matching fail? Was the payment approved? Did we just never get that event to begin with? Now, without the audit trail, answering those questions becomes guesswork, or you have to sit and look through your code for hours to try and figure out what actually went wrong there. So an audit trail can be something as simple as recording each significant event in your application's database so that you can go and look at it. And then tools like Datadog, Sentry, or Bugsnag then complement that, helping you to investigate failures and monitor your system in production. So to summarize all these tools, DTOs solve differences in data, enums solve differences in language, adapters solve differences in behavior, and audit trails provide traceability. So like I said earlier, these are good software engineering practices in general, regardless of the domain. But in the payments, they transform adding a new provider from a major refactor to just a small implementation detail. So this is a flow I trust, a resilient flow. We've spoken about each of these patterns individually, but they're even more powerful when we're able to put them together. So if I were building a payment flow today, this is the architecture I would aim for. Step one, we're going to validate. We want to make sure that it's a valid request. It comes from the correct provider. The payload hasn't been tampered with. And if those checks fail, we then just cancel that immediately. Step two, we want to normalize. So this is where our adapter and our adapter translates the provider's payload into our DTO. And once that happens, the rest of our application never needs to care whether the payment came from Airwallex, HSBC, Stripe, or any other future provider you might be adding. So you notice this ties all our tools together. It's the adapter, the DTO, and the enum. Next, we'll have a queue. So payments are asynchronous by nature. So there's no reason to keep the provider waiting while we do all the work. We acknowledge the webhook quickly, and then we let Laravel's queue do everything else in the background. Step 4 is to then update the state, not simply from unpaid to paid, but through a proper life cycle. So pending, authorized, captured, settled, because our business decisions depend on those states. And then we have our audit. So finally, we record what happened, not because we're expecting things to fail, but because eventually they will fail. And we want to be able to answer those important questions. So why is the system pending? The system should be able to answer that question without you having to go dig around in anything. So if you notice this flow, every step has its own responsibility. Validation validates, adapters translate, the DTO carries data, queues process the work, and state models business decisions. So audit trails also explain then what happened. And that makes the system easier to reason about as it grows. Okay, so the final outcomes. So at the beginning of this talk, I said payment systems sound very simple, right? Customer pays, the provider confirms it, and the system updates. But unfortunately, none of us get to build that type of payment system. We build systems where confirmations are delayed, webhooks arrive twice, references don't match, and providers don't agree with each other. And sometimes our own application has to make decisions with incomplete information. So the goal isn't to eliminate that complexity, it's to contain it. And that's why we care about safe retries, clear state, and traceability. So reliable payments aren't built for everything to go right. They're built to make sure that when things do go wrong, your system is safe, because they are inevitably going to go wrong. And fortunately, Laravel gives us exactly the tools we need in order to have that kind of system. So yeah, that's the end of the presentation. I think now we can open to questions.
Yeah. So I actually do have a question. Okay, cool. Thank you. That was a very fantastic view of the thing. And I think it would be a really good talk for juniors and intermediates to be introduced to these concepts. One area that I actually don't know super well, because I'm fairly new to the e-commerce world, and I think you might look a bit, is the area of fraud. Because I think with payments, even if someone's going to set up an e-commerce store now, that's a side they don't think about.
Yeah.
Even if they get all this right, then you suddenly have people using your site as a mechanism to commit fraud. And that's a difficult question, but do you have any kind of like rough thoughts on what people could do as a best practice to handle that side of things?
I think fraud is such a broad topic, and at Tillo, we actually have quite a huge initiative right now for fraud, because I think people are getting desperate, so there's more and more fraud happening out there.
Yeah.
I think one of the things that we've really been working on right now is that you can't always, fraud might happen in your system.
Okay.
And being able to identify that quickly and to stop it quickly. So having mechanisms in place to block that payment if you notice there's something going on, to alert the customer immediately or to alert us immediately. That's one of the things that I think you should build into your system early. Yeah, like
Okay.
having locks in place, but I think there's so many more. There's so many more than that. But yeah, I don't know. We can also open it up to the floor if anyone else has had any experiences like that, any fraud experiences.
Hey, yeah, I don't have any fraud experiences recently to speak of, so I guess I have a different question. Yeah, I can feel the pain of everyone has different sort of formats and responses and data things. I think I've seen that in sort of every business domain ever. Nobody agrees on anything. So more of a fun one. What's the weirdest webhook format you guys have seen coming in? And name and shame.
I worked on a payment integration for DTO, and that was quite messy because they had multiple payloads telling me the same thing. So the webhook that would come in would look completely different from another webhook. In fact, it was so bad that they actually told me, don't rely on our webhooks. So yeah, I think that was the most challenging experience.
Well, a couple of DTOs.
Yeah. Yeah.
Was that one open to the floor for the worst problems?
Yeah. I think so.
This was one South African payment provider. You can probably remember who these are. John, help name and shame, where the payload that you send to them, you must build up a JSON payload, stringify it, then hash it, add that hash to the original JSON array, and then send it. Also, if the keys in your array are not in the correct order, it gets thrown away. Who does that? Cash. Oh.
My question is, did the documentation tell you all that, or did you have to figure it out?
What documentation?
The real joy with that one was when their ordering of the JSON array did not match what JSON would defaultly decode to either, because there is no ordering in JSON, right? So it wasn't an alphanumeric order. It was just a YOLO. This is the order you must give us, which means if you just encode and decode it, it's just gone. You gotta reset every key in the right order that they wanted. Yeah, fun.
How long did that integration take you?
Too long.
Yeah,
Too many gray hairs.
I can imagine.
Oh, that's still live in production. If you're using the APIs today.
Is that my
I think Jerry has a question.
Yeah, maybe just a good one since everybody's like sharing their bad stories. Oh, I you know, their awful stories. I wanted to ask, especially in your experience, because you, of course, have done many of these. What I've seen with the couple that have done payment integration, of course, and even with some of the stuff that we have in storefront right now in the storefront team in Tillo, the flows as far as the different providers. You know, some it's a 3-step payment, some it's more, and like you said, you know, what's your what's your best practice or best advice when it comes to how to handle these, different flows, some longer, some shorter, and I know you've given the basics, the principles like DTOs and enums and stuff, but then when it comes to those flows and some that are going further, some that have also their own fraud detection and systems. So maybe just clarify a little bit on that and share your thoughts. Thank you.
I can tell you what we did at my previous company when we had this type of situation. We had a service for each one then, which I don't know if that's the best practice, but it's what we had to do because of that big difference between the providers. But yeah, what do you have any experience with that? How do you guys handle that?
How do we handle it? I think there's we do have services handling them. Now I'm sure if any storefront engineer is watching this, probably gonna choke me tomorrow. But so what we've done to deal with, I mean, ours is not that much different, of course, when it comes to the waiting period and stuff. So it's been decoupled. We're heavily using DTOs, relying on the enums and stuff. I think we've really made use of some of the information that you've given here, and maybe the one thing as well that's that is done is, of course, relying on queues and background system that and of course your webhooks to heavily follow up on that. And I think one cool thing maybe to finish with that is that most often, especially when it comes to like Jason mentioned, we do gift card. So especially when it comes to gift card, we do have an opportunity to just tell you, cool, your payment is cool, we'll send you the gift card later, or you will get it, so it gives a little bit of a window, that's longer than your 1 second, 30 seconds, so that everything else, every other background check, so to call it, can then be done. And then at the end of it, we can just send the client their gift card, or tell them that something went wrong because they ultimately had to wait a little bit. So maybe that's an edge that we have, but I don't think it will work for every business. I mean, most things needs to be like, I pay now, give it to me now. So I guess you just have to figure out what works for you. Yeah.
Like I say, cool. I got a question that is not tightly coupled to the code. But working with payments, we know there's one facet of payments, which is the code itself, that executes it. But there's also this era that we live in now, which is called IoT. So hardware is also a critical part of that. When looking at traceability, and Jerry spoke about queuing systems, payments is typically a high transactional architectural environment. What type of engines or tools do you normally suggest one use when it comes to this? If we speak about resilience and tying everything together.
I don't want to tell you guys this is my manager. He's really throwing me in. I think Imtiaz, you can give us the answer to that question.
Cool. What's worked for me? We'll talk about this in stand up. I'm joking. Yeah, it's been an interesting space when it comes to payments, and something I've been playing around is Tiger Beetle. I'm not sure if anybody's familiar with it. And Postgres and all these other tools are quite great, but when you're looking at high transactional scales, 50,000 records, 100,000 records per second makes sense. But once you go into the big tiers, like the banks and bigger transactions like Stripe, those numbers or the architecture in terms of hardware doesn't really cater for that. And for me, something that I found quite fascinating is that as technology is moving, the speed of data is also moving. So coming up with or using better technology in terms of architecture up front caters for that. Yeah, you don't want to get to a point where you have to refactor code or relook at your architecture to get to that point. Yeah, But I guess it's an interesting question because payments is kind of like one of the biggest talks in the tech world today. Does anybody have any suggestions in terms of engines or things that they are using to cater for these things?
It'd be cool to explain why Tiger Beetle is as cool as it is.
Cool. Why I like Tiger Beetle. Capitec is also this is recorded, but Capitec is also playing with it, and it was kind of open source for quite a while, and in beta. The reason why I do like Tiger Beetle is it's purely for transactional data in terms of high transactions. When it speaks to observe
That word, yeah.
that word, right? And having to be able to process transactions. If you compare that and do benchmarks between Postgres, MariaDB, all the other type of DB agents that we use, Tiger Beetle is actually 1,000 times faster. And it's not a material quote. They actually have stats to prove that. And for me, that was something quite cool. And it also has a built-in general ledger, which is actually made for payment. So talking about tools, it's quite cool to know that there's a DB engine that caters for those type of things as well. So when you're looking at refunding, try mechanisms, it actually caters for those states as well. So yeah, I don't know if any, you had your hand up.
We just we constantly doing off the jobs constantly.
Mm.
Just running buses and batches
and all that kind of stuff, and just build more and more jobs for handling all of the data, manipulation, translation, adaptation, and then it runs through each service to translate through that.
How do you spend the job?
AWS goes pretty big. We've got quite a big budget for that kind of side of things. So yeah, we did try SQS, but it just wasn't scalable enough.
Mm.
And so we just brought it all back to PHP Redis and run it all through Laravel in a much more natural way. Yeah.
Yeah.
Yeah, so we run, it's a couple of million a month jobs wise. Yeah. But it's a small setup. It's quite specific. We're not doing massive transactions like banks or that kind of stuff, but we also do other things with various other APIs, data translation, sports results, TV feeds, all of that kind of stuff. Yeah.
Cool. Interesting. Yeah, we have one year in the front.
Yeah, that's good.
Sorry, my question is simply to just clarify, right? Like, are you guys like a platform that built like payment systems that allow systems to be like people to make payment, or are you a platform that like uses unavailable system like Stripes or Paystack or Pay whatever to make payments, gateways or something? I don't understand.
Yeah, we use systems to facilitate payments. So we don't have Stripe yet, but I've heard some talk about Stripe in the background there. Right now we use Airwallex and HSBC.
Oh,
Well,
yeah.
that's on our team. I think the rest of you use Stripe. Okay.
Okay, cool. I see. Thanks.
Yeah.
So you mentioned state and having clear state. Are you guys a fan of doing a full state machine and having specific flows through it? Is that noise? Where's your like balance between having a state machine only allowing certain state transfers versus reality, which often isn't that?
We don't actually use the full payment cycle state. So what we do is we filter out webhooks so we use Zapier as a middleman, and we filter out webhooks that don't have the status we're specifically looking for. So we only want paid statuses to come through our system. I think for HSBC we do update it to pending and like different states that we may have. But for stable coins, we only get paid statuses. Yeah.
Speak to us on the storefront side. If you're talking more like statuses within the code, as in like it can move between paid, rejected, whatever.
Yeah, we've recently started relooking at the architecture there because a lot of it is there, but it's manual. So we're doing a lot of like, if this state, these are the possible states and handling that. But we're looking within one of our teams, which is kind of, so to explain, so Tillo is mostly an API kind of service, but there's one team where we kind of build the front end as well for a company. So someone would say, we would like to sell gift cards. We don't want to build an e-commerce store. We'd be like, sweet, we'll build you an e-commerce store. We'll just hook it up to your domain. Cool. So within that world, with states matter a lot because now we're handling the whole e-commerce flow on top of the API side of things. So we're looking at Laravel model states for that, and it's looking pretty solid, like just in some early testing. But yeah, right now it's very manual. Yeah.
Yeah, just to add on that as well, the whole adapter and this architecture that Tasmyn has gracefully presented, state actually came by nature, because once you start going into an architecture like this, state is needed. Because when we speak about retries, and there's the word clear state as well, we need to think about, cool, if something is going forward, how can we go backward? Because like Tasmyn has said, that we need to cater and have the idea that a payment can fail. And because it's on our side, what do we do about that? We're not going to look at the payment provider and call them and say, cool, the payment's done. Payment's honored on our side. And that's kind of where we're going. But to answer your question, we kind of want to balance that and don't want to go through a full state machine where this thing is going into like a loop. So yeah, it's kind of that. And then adding tests between that to test the state as well. So a bit of a lean state machine.
Hello, hi guys. Yeah, I just wanted to ask, like, let's say you'd want to plug in billing, right, in that flow. Let's say for HSBC, there's a particular billing structure that you have, and for Stripe, you have another billing structure, and you want to plug it in into that flow. Like, how would you go about doing that? I'm not sure, like, if you have like such a system where you have billing, but let's say you create another system that has a billing component in it. How do you think we should go about like adding it into that system, into that flow?
Well, I mean, follow the same architecture, right? For that. I haven't necessarily built a billing system myself. So I think there's some there's some people who have built a billing system here before. So I think we can open it up to them.
Yeah, you just with Stripe, you just run through the subscription API service and you listen for those webhooks. So you understand the webhooks for the subscription model. Laravel's already got it built in with the cashier and that kind of stuff. And then you just tokenize that and run that through the system. So then you would have a subscription service and a payment service, and and then you listen to the various webhooks. Like Stripe, you can just, like you say, you just listen to payment received or charge received or whatever your choice is, depending on what you want. And then if there is other flow ones you want to capture, then you just add those services and you add those webhooks, and then you throw in your metadata so that everything correlates back to your data. And subscription is user based, whereas payments is
Sorry, this is my space. I love payments. Probably a lesson I learned a long time working with payments, multiple providers, banks, etc. The biggest lesson I learned was Stripe does a very good job in terms of providing these services and kind of creating the full suite. I think that's partially why they're so successful. Same like Stitch and Paystack. But the one thing if you're actually building your own application, the one thing that we quickly don't realize, and it's only after the fact, is, well, commercials doesn't look really great anymore. And that means your code has to be ripped out, right? And the point I'm trying to make is like, how do you create that defense mechanism in terms of code architecture where you use adapters and all of those type of things where you can say, cool, I got Stripe. If I need Stripe today, I can quickly switch over to Paystack. And kind of utilizing the payment services from the providers, but controlling that entire payment ecosystem. I call it the payment orchestration on our side, so that you can actually be flexible enough to move around. And to answer your question, on the billing side, I would actually build the core foundations within my system. Again, if Stripe falls out, I can actually build my own or use another provider.
No questions.
We're talking about chain of responsibility part of where like command query kind of thing. Essentially, every element in the processing queue, a certain interface they have to adapt to. So effectively, like he says, you have different processes, then you want to introduce a billing system. It just needs to implement certain interfaces so that it plugs into the chain of responsibility. So it's pretty much the behavioral pattern. So I saw some of your code snippet there where you have a factor inside a function. I just hope that that was just an example because you're supposed to inject that into the constructor.
Yeah.
So if you use the behavioral, the chain of responsibility pattern, effectively, if you have any part of a new system that has to participate in the whole orchestration, as far as it conforms to a protocol or interface, you can just drop it in there. And speaking of which, I was going to ask, I didn't see any place where you talked about automated testing.
Yeah,
Part of your
yeah,
system.
yeah. I think testing is a whole subject on its own, but yeah, it's super important. I think that's one of the things that we use a lot at Tillo. I think testing actually takes more development time than building features themselves. So yeah. Cool. I think.
Cool. Yeah. Thanks, everybody. You're welcome to have some drinks, have some more pizza, hang around. It's not a rush. We're about to be able to get some of you guys. Here we go.
Yeah.
That must be